The aim of this video is to explore the development of the medieval tenon joint, from the loosely fitted tapered tenons of the Anglo-Saxon tree-wrights to the accurately cut, square-shouldered and tightly fitted tenons that characterized the fully developed timber framing of the 13th century and beyond. I also aim to showcase what is possible with an axe when it comes to cutting straight, square joints, and to demonstrate that square-shouldered tenons, typical of later medieval timber framing, were within the skill set of an Anglo-Saxon tree-wright, even though, as we will explore later on, they did not choose to cut them in this way. I begin by marking out these elm wall posts with a string line, plumb bob and charcoal, marking the shoulders square by eye, and laying them out as the squared straight tenons of a fully developed timber frame that might have been made in the 13th century. This style of fully framed building, with accurately cut, tightly fitting joints that were draw-pegged together, began to replace Saxo-Norman building traditions around the 12th century. The timber-framed buildings of Roman Britain were also properly timber-framed. However, between the 6th and mid-12th centuries, almost all sub-Romano-British and Anglo-Saxon buildings were constructed of earth-fast posts buried in the ground. This is what gave them their stability, and so the constructors of the buildings, known as tree-wrights, from the Old English treewright, did not need to rely on accurately cut, tightly fitting joints. They instead used an entirely different building tradition, which we will explore later. For now, let's showcase that it was not necessarily a lack of skills or technology that led to the disappearance of the fully timber-framed tradition. These joints are possible to measure out and cut with just a string line and an axe. I start by roughing out the shoulder of the tenon, keeping away from the true line for now, so as not to cut past the intended shoulder. Once this notch is cut, the rest of the material can be levered off with an axe and mallet, splitting along the grain in the same way as you might with a chisel after cross-cutting with a saw. Elm is notorious for its interlocking grain, so in the case of my air-dried elm posts, this is somewhat easier said than done. Once close to the line, I hew it down on both sides with the axe to create a flat surface. To begin with, I cut the top half inch of the shoulder by using the axe as a chisel, placing it on the line and hitting it with a mallet. This gave me greater accuracy and a clean line when starting to cut the shoulder, as opposed to swinging and missing with the axe, cutting past the line. Once the line was established, I could cut the rest of the shoulder with regular axe blows, as it is a lot easier to be accurate when cutting in underneath the line than straight on top of it. I cut the two edges of the tenon shoulder next, to the line as reference points, before removing the rest of the wood in a straight line between them. I use the straight edge to check my surfaces. This is no more than a length of radially cleft oak, with a string line marked and cut to this straight line. Saws are not entirely necessary for any part of timber framing, and indeed axes were used to cut timber frame joints well into the 13th century, even as saws were becoming more common. My confidence grew with cutting these square shoulders with the axe, and I began to cut all the way to the line with swinging blows, rather than chiselling. So, we can see that cutting straight, squared and accurate tenons with an axe is well within the capabilities of any skilled hewer or woodcarver. Today, there are many axemen far more skilled than I am, and there is little doubt that any Anglo-Saxon tree-wright, likely born into the craft, had the skill with an axe to hew accurately whatever shape they desired. And so it is interesting that the timber building tradition of the Anglo-Saxons differed so markedly from the fully timber-framed tradition of the Roman and medieval periods. The Anglo-Saxon timber building tradition is characterized by buried earth-fast posts, which give the buildings their stability. the use of large, even extravagant amounts of timber within the walls and frames of these buildings, and the use of a relatively limited number of simple joints, all cut primarily with axes. These include tapered, loose-fitting tenons with shoulders that are not cut square or tight. Some posts were simply just tapered ends of a timber, with no tenon shoulder at all. These pseudo-tenons were set into mortise holes that were often square and very large, to take almost the entire end of the post timber. The joints used also include the tusk tenon, tightened with a wedge, the half-lap or tapered scarf with wooden tree nails, and tongue and groove planking. And although the Anglo-Saxon joints that have been found weren't made to be tight-fitting within their mortises, they rarely show rough tool marks, and are often fairly accurately squared or shaped, despite tapering. So the people who cut these joints were clearly doing so with both skill and care. This means that the Anglo-Saxons' indifference towards cutting square and tightly fitting mortise and tenon joints was likely due to other reasons than a lack of skill or care. The first is that tightly fitting joints are not necessary for stability in an earth-fast timber building, especially in Anglo-Saxon buildings which often had a multitude of closely spaced wall posts, either buried into the ground or set into wooden sills between earth-fast posts. These building traditions therefore have different construction processes as well, whereas timber-framed buildings are assembled and fitted first on the ground, before being raised and pegged together. Earth-fast timber buildings are constructed in situ, more organically, with each individual piece fitted to the last. In this case, the loosely fitting joints may have been intentional. If the tree-wrights had tried to make tightly fitting joints, and made a mistake where the tenon went into the mortise but not completely, it might be very hard to get an extremely heavy vertical post back out of that position in order to make adjustments, once it was partially wedged in. Perhaps loosely fitting tenons were beneficial in that regard. In other words, the tree-wright knew that the tenon would definitely slot into the much larger mortise with ease. As well as adapting to different construction strategies, perhaps the Anglo-Saxons held different aesthetic or symbolic values when it came to their buildings. During the 6th and early 7th centuries, the period of Anglo-Saxon kingdom formation, post ghosts in elite royal halls show a preference for walls made of cleft and squared hewn oak posts or planks, set edge to edge. Timber that is hewn square may have been preferred in higher status buildings for the extra labour it took to produce, and a building that made extravagant use of vast amounts of square hewn timber would represent a vast amount of labour and resources. This in turn signalled the owner's significant power and control over the surrounding area and people. Commanding the felling and processing of this timber and organising the building of the hall would have been an incredible logistical task, and quite possibly a visual display of power to all those who witnessed it. So perhaps what mattered to the Anglo-Saxons was the amount of processed timber they could put into a building, rather than the tightness or accuracy of its carpentry. This idea can be followed further when you compare the stability of the Anglo-Saxon world to the Roman or later medieval periods. In both of the latter, inheritance was passed down through generations at both elite and sometimes non-elite levels. The Roman Empire with its stone monuments was no doubt fascinated by legacy, and the divine right to rule of medieval kingship no doubt cultivated a sense of long-term thinking, as kings could now be succeeded by their children. In these worlds, it makes sense to build buildings and structures that could stand firmly on their own, raised off the damp ground and able to survive throughout generations. In the fraught and tumultuous world of the Anglo-Saxons, however, passing on inheritance was never guaranteed. Kings were either elected or took their position by force, and early Anglo-Saxon kings were rarely succeeded by their direct descendants. Thanes and Gessis did not have the right to pass on their property to their children before the 8th century. It passed back to the king or chieftain. An ambitious ruler's mindset might be very much about the how much power can I amass and display right now before it is taken from me. And in that respect, pouring a huge amount of effort and resources into an imposing earth-fast building whose foundations might rot in 50 years' time, might have been completely strategic to secure their power in that present moment, without thought to any descendants who were unlikely to inherit it anyway. A final point worth mentioning is that traditions are traditions for a reason. I originally planned to build this granary as a timber-framed building with accurately cut joints, and I was heavily influenced by the culture of traditional carpentry today. It took me several weeks to get past that desire to be perceived to do a good job by the standards of modern traditional timber framing, and instead to choose the more historically authentic and archaeologically correct approach of the tree-righted, tapered tenons, even though they seem relatively crude and primitive to us today. And this reluctance to diverge from tradition may well have applied to the Anglo-Saxons, and might help explain the relatively long-lasting earth-fast tradition even as buildings on the continent developed timber framing. The aim of this project is not to build the most efficient, long-lasting or solid structure I can, but to show, to the best of my ability, the culture, tools and techniques of Anglo-Saxon tree-wrights. And so I decided to recut all of my meticulously cut square-shouldered tenons. This is not a 13th century timber frame, it is an Anglo-Saxon granary, and so the design of the granary needs to change as well. It will feature earth-fast posts, tapered tenons and axe-cut mortises. To decide on the exact shape of my tenons, I consulted the archaeological evidence and as many known early medieval timber finds as I could. Starting at the 13th century and working backwards, we have the timber-framed posts from 13th century London, with square-cut shoulders and tenons fastened with draw pegs, indicative of a fully developed timber framing tradition. And the slightly earlier posts from London with the same techniques, although the shoulders are not cut fully square, they are rounded. Timber framing began to replace the earlier Saxon tree-wrights building tradition around the 12th century. This is the Saxo-Norman tapered tenon from Caisson 1 of the Hemington Bridge, dated to around 1100 AD. It was regularly squared and finely worked, but tapered and fitted loosely inside the mortise with a small and irregular shoulder. This is the tusk tenon from the Saxon watermill at Tamworth, dated to the middle of the 9th century. The tenon is again loosely fitted and irregular, but tightened with a wooden wedge driven through a hole in the tenon as it exits through the mortise. Tusk tenons do allow for a slightly tighter joint, however they seem to have been used mostly for horizontally joined timbers, rather than the vertical wall posts I am interested in joining. This is the Mercian tapered tenon from the Cromwell Bridge, dated to the early or mid-8th century. It is this design that I have decided to take inspiration from, as it is the most closely dated example that shows how a vertical post might be jointed into a horizontal sill beam, using the tapered tenons of the Saxon building tradition. This post is of course angled as it was used in a bridge caisson or footing, and the post sits on rounded shoulders which act only as a stop to prevent the post going any further into the mortise, rather than providing any stability. But the tenon was finely worked and smooth, and other aspects of the bridge caisson, such as octagonal tusk tenons, show that the tree-wrights took care in their work, even though the bridge footing was not likely to be seen or looked closely at by anyone. A final example to note is the tenons from the Ebbsfleet watermill in Kent, dated to 692 AD. These are quite unlikely to be heavy structural timbers, as the tenons are very thin at just 1 to 2 inches thick. They have an irregularly cut shoulder, with no attempt to make an accurate joint, if they were let into any mortise. But they are relatively finely and carefully worked. They have been interpreted as being involved with the lifting machinery of the watermill's wheel and millstone. And so the evidence has given me a potentially suitable design for the tapered ends of my granary wall posts, which will be let into the sill beam and support the walls, while buried earth-fast posts will support the roof independently. I briefly experimented with just rounding off my square shoulders to emulate the Cromwell bridge tenon, However, this felt too perfunctory, as my tenons still had accurately squared points at which they met the now tapered shoulder of the post. And so I cut every single tenon back by about 2 inches, tapering and rounding the shoulders into a decorative form of the Cromwell bridge tenons, with roughly squared tenons that tapered slightly from the shoulder to the end. I also cut faceted ends on each tenon to roughly square them off with the axe. As the majority of these will be through tenons, they will no longer need to be accurately squared. I am not sure how well these posts will work, and how much I will now need to rely on the stability of tie beams set on earth-fast posts to keep the wall structure from racking sideways. But that is the whole point of experimental archaeology, and so I am looking forward to cutting the mortises into the sills, and bringing this Anglo-Saxon granary one step closer to completion.